The block shown in the figure started from rest and moves towards the right. Assume pulley is frictionless. We are given block A that has a weight of 1000 newtons and block B that has a weight of 250 newtons. Given a coefficient of friction of 0.20, we are tasked to compute the velocity of the system when block B touches the ground. And to solve this problem, we consider the free body diagram of each figure, or each block. So considering block A, it has a weight going downwards that has a value of 1000 newtons. And due to the interaction between the block and the surface, it will feel a normal force that is equal to the weight of the block to keep the vertical forces in equilibrium. And then it feels a tensile force due to the cable, let's call this force T, and a frictional force due to the surface that has a value of mu times n, and we are given mu equal to 0.20, and the normal force of the block that is equal to 1000 newtons, which is just equal to 200 newtons. Now since this block is moving towards the right, it feels a net force of mass A times the acceleration. And to solve for the mass A, we divide the weight of block A of 1000 by the gravitational acceleration of 9.81, because weight is equal to m times g. To get m, we divide w by g. So the mass of block A, that is 1000 divided by 9.81, that is equal to 101.94 kilograms. Now taking summation forces horizontal equal to the mass times the acceleration of block A. So we have a tensile force going to the right minus the frictional force of 200 newtons equal to the mass of block A, that is 101.84 kilograms, times the acceleration. So we have two unknowns for this first equation. Next, we consider the free body diagram of block B that has a weight of 250 newtons and a tensile force going up, let's call this force T, that is equal to this tensile force connected to block A. And since block B is moving downwards, it feels a net force that is equal to the mass of block B times its acceleration. Now we take summation of forces vertical equal to mass of block B times acceleration. Considering upward forces to be positive, we have tensile force T minus 250 equal to mass of block B times the acceleration, and the sign for the net force, that is negative, since it is going downward. And to solve for the mass of block B, we divide the weight of block B, that is 250 newtons, by the gravitational acceleration of 9.81 meters per second squared to get the mass of block B. And that is just equal to 250 divided by 9.81 equal to 25.48 kilograms. So we have T minus 250 newtons equal to negative 25.48 kilograms times the acceleration. And this serves as our second equation. Now let's rearrange these two equations. We have T minus 101.94 times A equal to 200 newtons for the first equation. And for the second equation, we have T plus 25.48 times A equal to 250 newtons. Now we can use our calculator to solve for these two variables by going to mode 5.1. So we have T minus 101.94 equal to 200, and then T plus 25.48 equal to 250. We get T equal to 240 newtons, and the acceleration of the two blocks, that is equal to 0.39 meters per second squared. Or 0.3924 And then to compute for the velocity of the system when block B touches the ground, there is a distance of 2 meters. We use the equation in kinematics given the acceleration and the initial velocity but unknown final velocity, that is Vf squared equal to Vx squared plus 2at. To solve for the final velocity, that is equal to the square root of the initial velocity squared plus twice the acceleration times the distance d. We get Vf equal to square root of an initial velocity of 0 squared plus twice the acceleration of 0.3924 meters per second squared times a distance it travels of 2 meters. Now we get Vf equal to the square root of 2 times 0.3924 times 2 meters, and that is equal to 1.25 meters per second. And that is our final answer.